Alright, here's a couple of the words for properties of trapezoids. We're going to come back. Oh, that got crazy. We're going to come back and do these later. We're going to go over to the trapezoid notes page. Alright, and we're back. These are the main properties that you guys need to know. These are parallel. There's one set of parallel sides. There's more properties for isosceles trapezoids, but this is it for generic trapezoids. The fact that these angles are supplementary and these angles are supplementary it's like the main thing. They all four of them add up to 360. That's also important. But if you know, A is 65, and then you take 180 and you take 65 away from it, then you are left with 115, which is what angle C, no, it's D. What angle D would be, because they're going to be supplementary. So the ones that do not touch the same base, so the bases are the parallel sides, these touch different bases, they are supplementary to each other. Make sure you can identify them, you know, because sometimes the triangles will be sideways. It's not a triangle. Sometimes trapezoid will be sideways. You still have to identify, oh, these are the bases because they're parallel. So that would mean these are the same. And then same idea here. If this is 42, this is 138. And you know that because, oh, you can't see that. Because they are supplementary. 180 minus 42 is 138. I'll get my hand out of the way in a second. So that's angle C and angle D. And that's like the gist of like the main property for generic quadrilaterals. Why do I keep saying that? Generic trapezoids. There we go. But we are going to talk about medians as well, and we just got done talking about medians and triangles. These are a little different. They have similar properties, like they are connected by the midpoints, just like the midpoint to the vertex was the median of a triangle. But this is midpoint to midpoint for median of a trapezoid. The main thing you need to know is that the median of a trapezoid is equal to the mean. What is the mean also called? Yes, I heard a whisper. That was correct. It starts with an A. Let's have some confidence and say it. The average. Yeah, so the mean and the average are the same thing. If you average the bases, so add them together, divide by 2, it will always equal the value of the median, or like the length of the median. All right? And then the median bisects, so we know what that word means. It cuts in half the sides of the trapezoid. So, yeah, it connects to the midpoints. All right, let's do this thing. We're going to average the top and the bottom. 17 plus 47 divided by 2. You add 17 and 47, you get 64. Cut that in half. You end up getting, here, I'll write that equals KJ, 32. Yeah, so KJ equals 32. That is our median. All right. And then I'm going to show you 2 ways to solve for this one. You can choose. I feel like one is easier than the other, but I'm going to leave it up to you, however you feel more comfortable solving it. You can do just like we just did. You can add the bases together. One of them is going to be x because you don't know this side length, and set it equal to the median. Then you have to do some solving. It's not overly complicated, but there is a fraction, so you have to multiply by 2 on both sides to get rid of that fraction. So then you subtract 21. X equals 11. So, I mean, that's one way that you can solve for this. I think an easier way, if you can remember this way, is to just figure out, okay, what is the change from 21 to 16? Oh, we are subtracting 5 to get from here to here. And then we need to do the exact same thing to get from the middle to the other side. We need to subtract 5. So like if you were going this way, you would add 11 plus 5 is 16. 16 plus 5 is 21. It just depends on what direction you're going. You figure out the 2 that you have. What's the change from here to here? Did the same thing from here to here. That's how you get it. But yeah, you can use either way. That's fine. It doesn't matter. All right, we're going to look at this one here. So this one is sort of similar to the one on the assignment, but I think the numbers on the assignment are more confusing, so it throws people off. So just pay attention to how this is set up the same way on the assignment. 13 plus 11x plus 2. So I'm adding these together, the bases. I'm dividing by 2, setting equal to 24. It's a slightly more complicated because there's like an expression here and it's not just numbers, but it's the same idea. I'm going to go ahead and get rid of this fraction. This is not 24.2. It's not a decimal. We're multiplying. But this is going to be gotten rid of. I'm also going to go ahead and combine these like terms. The 13 and the 2 to just get that over with. When I multiply those, I get 48. If I subtract 15 on both sides, 11x equals 33. X equals 3. I will say that the ones on the assignment and possibly the ones on the quiz, I don't know for sure off the top of my head, you do have to plug that back in. So if that, if that is asked for, make sure you don't forget to do that. 11 times 3 is 33, plus 2 is 35. So like the length of BE would be 35. But there is an easier way to do this particular problem. I just wanted to set it up like this because the one that you will see on your assignment has expressions for all 3 of them. So I want to make sure you have an idea of how it gets set up. But like for this one, you can just add 9 and 27, divide by 2, and set it equal to 4x minus 14, and then you don't have to multiply on both sides. You can just figure this out. 9 plus 27 is 36. Cut that in half, it's 18. And it just makes the problem a lot easier. We're going to add 14 on both sides. So x equals 8. If it wants you to plug that in, just make sure you read the problem and you do that. And then once you have that, we're going to flip to the next page. Yeah, I'm going to pause my screen. I want you to set this up and solve it on your own. Make sure you plug it back into angle R. But based on this relationship, figure out how to set it up and solve. Okay, so this is how the problem is set up. And then, I'll just show it to you. As you solve, you should get x equals 12. Just make sure you add them together. You set them equal to 180. That's the gist of how you solve these. Once you solve for x, you plug it back in and you get this angle. That would mean that Q has to be 50 because they add up to 180. So if you want to check your answer, you can plug this in. 6 minus 12, or 6 times 12 minus 22 is going to be 50, so we're good. All right, let's move on to isosceles trapezoids. In order to do that, we need to, go get that, am I going too fast? Let's see. You need to flip back to page 4. We're going to write, it's just 3 words we're going to write real quick. Legs are congruent. The diagonals are also congruent. And then the base angles are congruent as well. Look at that. So there's 3 congruent things that the isosceles trapezoids have that are unique that generic trapezoids do not have. All right, so write those down. We're going to move back to page 8. These are called legs. These are called base angles. We have already discussed that these are called the bases. The base angles are the 2 angles that touch the same base. So like B and D both touch this base down here. They are congruent to each other. They're called base angles. These legs are always going to be congruent for isosceles trapezoids. An isosceles trapezoid is essentially an isosceles triangle with the top of it chopped off to where it's parallel with the base. But they kind of follow a lot of the same properties. When we talked about isosceles triangles, I don't know, maybe a month ago. So it wasn't too long ago. But yeah, these are the unique properties. It still has these properties here where like angle A and B are going to add to 180. That does not change from isosceles trapezoid to generic trapezoid. Yeah. So we can look at this and we can realize, oh, these are base angles. X and W are going to be the same as each other. Angle X is congruent to angle W. So we can set 110 equal to 17x plus 8. We can subtract 8 on both sides. 102 equals 17x. This actually comes out to a nice, pretty whole number of 6. But you don't actually have to solve for x in order to figure out what v is. Because these angles add to 180. So this, like x and y, are going to add to 180. Y and v are base angles. So I can put 2 markings on this one, 2 markings on this one. And show that that one is 70 as well. So both of these are 110, both of these are 70. They all 4 add up to 360. But yeah, that's a relationship that you need to be aware of. These are actually the same trapezoids because this is 110. Well, maybe the side lengths are different. I don't know. This is 110. This one's 70. This one's 70. So, just be able to identify which ones are the same, which ones add up to 180. And that's, that property for isosceles trapezoids that's going to pop up a lot. And then the legs are the same. So we know legs are congruent. Set them equal. X is going to be 4. So, just really those 3 properties that we talked about. Well, we've only talked about 2 of them so far. We haven't got to diagonals yet. But the legs being congruent and the base angles being congruent. As long as you can identify what legs are and what base angles are, it's pretty easy. Alright, last thing. Talking about the diagonals. Diagonals of an isosceles trapezoid are congruent. So that would mean AC is congruent to BD. So we can just set them equal to solve. 2x plus 3 equals 4x minus 7, and we can solve. So anytime it gives you that whole diagonal, set it equal to the other diagonal, and then you're done. So this becomes 2x. We'll add 7. So we'll do both things. We'll subtract 2x and we'll add 7. So 10 is going to equal 2x and x is 5. But yeah, just make sure this one just says to solve for x. Pay attention to what the question's asking and make sure you don't need to plug it back in to solve for one of the diagonals. Alright, we're looking at number 5 from the assignment real quick. You're going to set it up the same as we did for this example on the bottom of page 7. We're going to add the bases and divide by 2. We're going to set it equal to 4x plus 7.5. It's just when you multiply by 2 on both sides, make sure that you are distributing. So that 2 gets multiplied there and there. So it ends up becoming like 8x plus 15 on this side of the equation, but people forget to distribute the 2, and then it just messes everything up. So like, this gets canceled. That's that side of the equation, then you can continue on and solve. I just wanted to point that out because that's been something people have been struggling with today.